All right, so last problem. Problem 6 is from 2004, Form B, and it's question 4. Again, this is the type of problem that I think is likely to, or has a high probability of being selected for this year's test. So the principal at Crest Middle School, which enrolls only 6th grade students and 7th grade students, is interested in determining how much time students at that school spend on homework each night. The table below shows the mean and standard deviation of the amount of time spent on homework each night for a random sample of 26th grade students and a separate random sample of 27th grade students. So right there, we know we have 2 independent random samples. We have 6th grade students with a mean score and a standard deviation, and same with 7th grade. Now, we can assume that those standard deviations and means came from the sample. Otherwise, how did they get them? And they told us that they were taking a sample. As soon as they say mean, and as soon as I have standard deviation, I go, all right, I'm running a t-test, all right? So I know I'm running a t-test, and because I have 2 samples, the 2 sample t. They tell us, based on dot plots of these data, it's not unreasonable to assume that the distribution for each grade were approximately normally distributed. We need to not forget that that's going to be important information. Then it says, estimate the mean time spent on homework for all 6th and 7th grade students in the school using an interval. And so they use the word difference. And so then it says, be sure to interpret your interval. They don't need to tell us to be sure to do that. We should always do this. They tell us specifically they want us to use an interval. So we're going to use an interval, not a hypothesis test. So you do not need to state the null and alternative. I tend to always like to do that just to remind myself that, okay, confidence interval is two-tailed. Don't forget that because that can apply to other problems. So don't forget confidence interval is two-tailed. And then also when I do that, I always go, oh yeah, I need to define my mean. So I put mu1 is the mean amount of time on homework by 6th graders, and this should said the true population mean. And this should be the true population mean amount of time spent on homework by 7th graders. I slipped and didn't put true population mean. I needed to do that, or should have done that. Conditions, 2 random samples of 20 given, or are given. Need to make sure that we're less than 10% of the population. Once again, they were not requiring this back in 2004. They are now requiring it. Make sure you do it. So 20 divided by 0.1, there's going to be at least 200 6th graders is what we're going to assume. And the same for 7th graders. There's going to be at least 200 7th graders. And we do that in order because we are sampling without replacement. All right, normality of the problems is given by the dot plots as stated in the problem. So they've already told us normality of the populations is given. We need to make sure, even though they said it, we need to make sure that we state that because that is a condition for running this test. All right, so we record our formula and you'll have access to that on one of the charts. And this number right here, it always seems odd. We're going to go ahead and run the test all the way through, and then that will give us this number. Okay? So at this point, I'm going to start plugging in values that I know. I know that 27.3 is the mean for 6th graders. I know that 7th graders have a mean of 47. Standard deviation is 10.8 for 6th graders, and standard deviation for 7th graders was 12.4. I cannot calculate this yet, so technically I have a blank there. I'm going to need those degrees of freedom in order to do that. But we will do that at the very end of things. Now, they did not tell me what confidence level to use. I chose 95%. You could have chosen something different, and that would have been all acceptable. So here we go. Scoot that up just a little further. And stat, test, scroll all the way down to 2 sample t interval. 6th graders had 27.3 average. They had a 10.8 for their standard deviation, sample size of 20, whereas 7th graders was 47, standard deviation of 12.4, and a sample size of 10, confidence level of 0.95. And when we are working with means, we never pool. All right? So when I do that, I get my interval, and I'm going to go ahead and write that interval down because I'm going to need it. Negative 27.15 and negative 12.25. And by the way, you might have done seventh graders minus sixth graders, in which case you're going to get the same values, but it's going to be positive. That's perfectly acceptable, 100% good. All right? So there's my degrees of freedom. I need to write that down because we need to use that later on. So I've written all the information I have down, and right now I have this value, these, and all these values, but I'm still missing my T star value. So I need to go calculate my T star, and that's what I need the degrees of freedom for. So second vars, inverse T, 1 minus 0.95 divided by 2. This is my degrees of freedom. And I end up getting a value of 2.0256. So this is my T star value. So that's where that came from. All right, so our conclusion, we always have to have this, it's not optional. We are 95% confident that the true population difference of mean homework times between 6th and 7th graders, or 6th minus 7th graders, lies with the interval negative 27.15 and negative 12.25. If you had done 7th graders minus 6th graders, this order would have not needed to switch to 7th graders minus 6th graders. Always include the order you did. Okay, now, is there anything I noticed about this? Well, what I noticed is 0 is not included. And I probably want to make some comment because, and I can sit there and go, you know what, because 0 is not included, it appears that on average, 7th graders have more homework than 6th graders, or spend more time on homework than 6th graders. They didn't ask that, it wasn't required, but I'm telling you, it's a good thing to include, all right? You definitely need to know how to do it because they often ask that. And again, that would be something I would expect them to ask. An assistant principal reasoned that a much narrower confidence interval could be obtained if the students were paired based on the responses. For example, pairing the 6th grade student and the 7th grade student with the highest number of minutes spent on homework, 6th grade student and 7th grade student with the highest number of minutes spent on homework, and so on. Is the assistant principal correct in thinking that matching students in this way and computing a matched pair's confidence interval is a better procedure than the one used in Part A? Explain why or why not. Well, I can't just assign people together. There has to be some sort of natural pairing. So this would not be inappropriate. First off, these are 2 independent random samples, so not appropriate for that reason. But to be paired, students paired must share some characteristic that impacts the study. For example, it could be the same student who was surveyed in 6th grade and then again in 7th grade. So if I surveyed someone twice, certainly would be appropriate to do, that would be a time when I could do a paired test. Quite frankly, if I had siblings, 1 in 6 and 1 in 7, that might be reasonable to do so. But we cannot just sit there and go, you know what? They spend the most time in 6 and those spend the most time in 7th. Pair those together. That doesn't work that way because there was no relationship, no natural relationship between the two, or between the pair.